Now, the interesting thing is we talked about catalysts in the previous chapter on kinetics, and we said that they increase the rate of a reaction by lowering the activation energy. Now, you'll notice what that means, though, is if I've made going this way the hump smaller, then coming this way the hump is also going to be smaller. So both the forward reaction and the reverse reaction are going to have a smaller activation energy, and those rates will both go up. And as a result, the catalyst does not affect the equilibrium constant at all. It does make everything happen faster, but equilibrium isn't about the speed of things. That's the realm of kinetics. And now we turn to calculations, because earlier we did that when we just said which way it shifted. We didn't talk about how did the numbers change. This is how we're going to deal with the fact the numbers change and to calculate them. We are going to use what in this book are called rice tables. In other books you may see them, or you may have already learned about them, as ice tables. It's very important what the reaction actually is. So our book decides they're going to add an R to that and make it a rice table so that you always write down the reaction so that you don't make mistakes when you're writing up your table. I'm going to make hydrogen iodide from hydrogen gas and iodine as a gas. I'm told what K sub P is. Okay, so that's a pressure-based one. And it asks, what's the partial pressure of HI at equilibrium if it started out with no hydrogen iodide and we had hydrogen and iodine present at 0.1 atmospheres. We said R was the reaction, right? So we will write down the reaction. H2 and I2 and 2HI, which is going to be also gases. I'm also going to remind myself, K sub P is 50. I says I want to write down the initial concentrations. Well, I was told this was 0.100, so was this, and that initially there wasn't any. You can see if I tried to figure out what K is here, I would just end up with a big fat 0. So my Q would be a 0. K is bigger than Q, it's got to go this way. Well, that makes sense. It's got to go that way because there's none of it. It certainly couldn't go that way. You can't get less than 0 as an amount of a chemical. Next is the change. Well, I just got through saying it was going to have to go that way, right? So this is going to get used up. I don't know how much of it is going to get used up. That's why I'm using the X. And this is a 1-to-1 ratio, right? So if X of this gets used, X of this is going to get used. What's going to happen as a result? Well, that's a 1, so is that. But this is a 2. So this is going to increase by 2x. Now, the other thing I like to do on my tables is to remind myself which side is which. So I like to fill in where this is with a couple of parallel lines to separate my reactants and my products. So what's the equilibrium? Well, after this is all done happening, then my concentration is this. Same for this one. And this is going to be 2x. I know that K sub P is calculated by taking the products. So that's your 2x. And because there's a 2 here, it gets squared. Now that bothers people a lot because it seems like I'm double counting, right? I used the fact that it created 2 to put a 2 here. And I'm also using the fact there's a 2 to put a 2 here. Yep, that's exactly how it's done. It is not double counting. That is exactly what you have to do. On the bottom, I have the reactants. 100 minus X. And they're exactly the same thing in this one, so I'll just go ahead and do this. But remember, I did that because these are both the same thing, not because of any of the coefficients. And I know that this has to equal 50 because they told me that. So now it's time to turn all this into a quadratic equation. I'll take this and multiply both sides by it, right? So that I will have 2x that is being squared equals 50, and then I'll have 0.100 minus x being squared. 4x squared equals 50 times 0.0100 minus 0.2x plus x squared. And now I'll distribute that 0.5 minus 10x plus 50x squared. Combine everything together by taking this and bringing it over here. So 0 equals, and now I'll write it in the order I would expect to see it if I'm trying to solve it. 46x squared minus 10x plus 0.5. And it's time to use your quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac, all of this over 2a. And then I would just have to identify what all these are. That's a, that's b, and that's c. So let's put those in there. This is a minus, that is okay, so I'm going to have a positive 10. Plus or minus, and this might make you nervous, as well it should. B squared will be 100, and then minus 4 times a and times c. And then over 2a, so 2 times 46 is 92. This ends up being 10 plus or minus the square root of 8 over 92. Ultimately, I only have 2 sig figs here, so I will go ahead and say that this is 10 plus or minus 2.8 over 92. I will get 2 possible answers because it's a quadratic formula, right? So I get 2 possible answers. There should be only 1 answer. I'm doing a chemistry problem. So let's think about what these mean in a real situation. This x, this says 0.139. Let's go back up here. If I did that, if I took 0.139 away from 0.1, I would end up with a negative number. That would be a negative amount of hydrogen, and that's not possible. So this one is an extraneous solution because it doesn't work in reality. Only the x equals 0.078 is physically possible. And this is what you will find in all of your rice table dealings, is if you end up with more than 1 answer, only one of them will actually be physically real. We're just going to have to make sure that we have a molarity that is positive, and we'll be able to get rid of the extraneous solutions. So now I would like to know, what is the value of H2? I know that we started with equal values and they changed by the same amount. So the concentration of hydrogen and the concentration of iodine are both going to be the same, and they're both going to be 0.100 minus 0.078, which means that they are both going to be 0.022 atmospheres. Oh, see, I shouldn't have written concentration. This should really be pressure of hydrogen and pressure of the iodine as gases. And the pressure of the hydrogen iodide at equilibrium should be 2 times x. So that would be 2 times the 0.078, 0.156 atmospheres. Now, if you took this and ran it through to figure out what Q is, it should now match what KP is to 2 sig figs. See, I've kind of got 3 right now, but I would go ahead and run it with these numbers, and then you'll see that it matches the K sub P.